to 5th grade problems. Do you remember that they were just whole numbers, and multiplying whole numbers is a little too easy for us right now, you know, like 6 times 7 or whatever. So we changed the numbers to add a decimal into them, okay? So who remembers the strategy we used when we multiplied with decimals?
We multiplied the decimal number times the whole number, and then we counted how many digits were behind the decimal.
Okay, you're right. You guys remember that? Did we ignore the decimal to start with? Totally. So that would be just like doing 2 times 2, correct? Okay. And then we counted how many digits were behind the decimal, exactly what Dusty said. And we made sure our answer has that many behind the decimal. So this answer would be 0.4. How do you say that number? 4/10. And does it have 1 digit behind the decimal?
Yes.
Okay. You can write this as we go. So in this one, I'm going to have to combine those. So how many digits behind the decimal in this one? 2. So it would be 0.04. And how do you say that number? 400ths. And do you remember I said tenths times tenths is hundredths?
Yeah.
Okay. So that makes perfect sense there. Now this one is hundredths times tenths. So how many total digits behind the decimal this time? 3. So I will need 3 digits behind the decimal in my answer. How do I say this number? Just say it.
4,000.
4,000ths. Now I want everybody to put the pencil down, because I'm going to have you finish this, but before you do, I want to ask a question. What if they wrote the problem vertical?
It's the same thing.
It's the same thing. There's no reason to use turtle head multiplication on this problem, because you know what 2 times 2 is. 4. All you would do is count how many digits behind the decimal. 3 total. So you would need 3 total behind the decimal in your answer. Okay? So it's the exact same thing, even if it's not written horizontally. Okay? All right, go ahead and finish these, and then we'll say answers by table groups. All right, so table 1, well, we already know what 3 times 4 is. Can you tell me what the answer is on the next problem?
1.2.
1.2. How do you say that?
1 and 2 tenths.
1 and 2 tenths, okay? And table 2, what's my answer here?
Wait, what? 0. Yeah. 0.12.
Good. How do I say that? 1200ths. Table 3, what do I write here?
12,000.
Good. Is that how you write 12,000? Okay, and then going down, 5 times 7 is what?
35.
Okay, so table 4, how do I write it here? 3.5. How do I say that?
3.
3 and 5/10 or 3?
3.5. 3.5.
3.5. Good. Okay, so what about this one? Table 1, it's your turn again.
0.35.
Okay, how do I say that?
3,500.
Very good. And table 2,
0.035.
how do I say that?
35,000.
Very good. Okay, so that's kind of new. All right, you're probably going to see that on assessments. It'll be a problem like with area or something, and you'll have to know what to do with the decimals when you multiply. Okay? All right, so let's look at this one. Okay? Now, I feel like you learned this in 4th grade, and I'm going to show you a visual on the first one. Make sure you're on the right box. Don't flip it over just yet. There we go. Okay? So here's a visual for you. Somebody tell me what you think that means that we're going to do. Okay? Multiply the denominator times the whole number. Okay? And then what do I do with the 1?
Keep it.
What do you think, Kyle?
You times the whole number.
You're close. Whatever you get when you multiply, then what do I do with the 1?
Switch it to that. You
Okay.
multiply that times the 1.
You're close. You're going to add the 1 in. Is that what you were going to say, Kaylin? Okay, so you're going to multiply the whole number times your denominator, that's 8, and add 1,
9.
and it gives me an improper fraction. My denominator does not change. How many of you remember this from 4th grade? You just forgot it. Okay, well, I know Kaylin did. So if I do the same thing here, you don't have to draw that. I'm just giving you a visual. 2 times 4, table 3. What's 2 times 4?
8.
Plus 3.
11.
So it's going to be 11.
4.
Okay, finish these and then we'll have table group's answer. Okay, table 4, what's my answer for the next one? 5. How do you say that? Anybody know? Halves. 5 halves. Okay. Table 1.
14 thirds.
Okay. Table 2.
15 fourths.
Good. Table 3.
17 sixths.
Table 4.
27 eighths.
Table 1.
37 eighths.
And table 2.
47 eighths.
All right. Any questions on how to change a mixed number to an improper fraction? It's pretty simple, isn't it? Okay, I want to skip the next one, but I want to make sure we come back to it. Okay? So go ahead and move on to the application problem. Okay, now this problem is about raised flower beds, and I wanted to show you a picture of it so you'll know kind of what we're thinking when I'm reading through this. So a raised flower bed is just going, these look like tomato plants though, don't they?
Yeah.
But so they could be vegetables too. But they are made in the grass, but they're raised up from the grass, and then I think you put a barrier down to kill the grass underneath so that the grass isn't coming into your vegetable garden or your flower beds all the time. Okay? You know what I mean by a barrier? It's like that stuff you roll out. Okay. All right. So this problem is about a raised flower bed. It's not exactly like those, but you get the idea. Heidi and Andrew designed 2 raised flower beds for their garden. Heidi's flower bed was 5 feet long by 3 feet wide, and Andrew's flower bed was the same length, but twice as wide. Calculate how many cubic feet of soil they need to buy to have a soil to a depth of 2 feet in both flower beds. Now, this is pretty complicated. I see long and I see wide, so I know it's length and width. What else do you see in there that's important? Aaron?
Twice.
Okay.
Twice as wide.
Okay, I'm looking for words, not numbers.
The width.
The depth. Yeah. Do you remember I told you sometimes depth can be substituted for one of your dimensions? Okay. So that really means how deep it is. Okay. What else do you see that's very, very important? In fact, this is more important than anything else we've mentioned. Kyle?
Feet.
You're close. What word is in front of it?
Cubic.
Okay, so what does that tell me? Cubic. What's it tell me, Ashley?
But your label is going to be cubic.
The label's going to be...
Times width times height.
And what kind of problem is this?
Volume.
Volume. Okay. So what they're trying to trick you into doing, first of all, is to just doing length times width and making it area. Okay? And we're not going to fall for that, are we? Because we know what cubic stands for. So let's figure out the size of Heidi's bed and figure out the size of Andrew's bed and then decide how much soil we're going to have to buy. Okay? So Heidi's bed was 5 feet long by 3 feet wide. And then what was the depth? 2 feet. And that's how deep the soil is. Okay? So Andrew's bed was the same length. So how long is it?
5 feet.
Okay. But but it's twice as wide. So instead of 3 feet wide, 6 feet wide. And then does it also have a depth of 2 feet?
Yes.
Okay, so to figure out the total amount of soil you need to buy, will you have to add Heidi and Andrew's beds together? Yes, okay. Go ahead and solve this problem, then we'll talk about it. All right, so on this first one, Heidi's bed, what did you multiply first?
5 times 2.
5
times
You did 5 times 3 and doubled it, so what do you get?
30 feet. Feet and
Cubic feet.
cubic feet.
Right, how many of you forgot your 3?
Imagine.
Okay, and on this one, did you do 12 times 5 or 30 times 2?
I did 30 times 2. I doubled 60 cubic feet.
All right, and my total
Is 90 feet cubic. Oh,
cubic feet. Okay. Any questions on how to do that? And then they have bags of soil, and on the label for mulch, I know this for sure, it says cubic feet. It says this covers this many cubic feet. So now you know what that really means.
And it has a really soft
Okay, so the lesson today actually goes along with the first page of the problem set. So that's why you have a copy of the problem set. You need both pages in front of you. So you have a copy of this chart. Okay, turn to that page. And you also have a copy of the problem set. And I'm going to have to flip back and forth between those 2 pages. Okay. Okay, so today we're going to work on the area of rectangles. But one of our side links is going to be a mixed number. So this is different than any multiplication you've done so far. Okay? Now the first one, I think, is just a review of how to do area. Okay? So what I'm going to do is I'm going to drag the tiles down here. And we're going to see how many square tiles cover this rectangle. And then that'll be a review of how to do area. So we've got, you think it's going to be 6?
Yeah.
That was pretty fast. Okay. And if I were going to label this, which you're going to do when we get to the problem set, okay? But if I were going to label this, I would write 3 units times 2 units, okay? And you're going to do that when we get to the problem set. So now, for the sake of this activity, I need you to really listen here. The length is going to be on top, and the width will be on the side. So I've got 3 units, you can write this on your chart, times 2 units. And what's my total area? 6 square units. Right, square units. Okay, now when we get to the problem set, all we have to do is draw this, label it, and then fill in some blanks. Okay? So let's look at, fit to width on that. Let's look at this rectangle A. So we're just going to draw a rectangle here. Oops, that's a line. Just draw a rectangle. And remind me what we labeled our rectangle as.
Rectangle A.
Yeah, we got that. How many units were on the top? 3 units
Times 2 units.
times 2 units. And so it looks something like that, only straighter than mine. Okay. And so, you got that drawn? Am I rushing you?
No.
Okay.
Wait a bit.
So rectangle A is 3 units by 2 units, and that equals 6 square units. So this is reminding us that length times width equals area. Now what happens if I have a side length that's a mixed number? That means a number mixed up with a fraction. Okay? So let's look at this one. You can put your pencils down for right now. Okay? If I'm going to cover this one, this looks a little taller, doesn't it? If I'm going to cover this one, what do you think my total's going to be? 9?
Wait.
If I drag that down, is that too big? Yeah.
I think it's gonna
So that won't work.
I think it's gonna be six.
Well, there's 6.
No, a 6 and a half. 7. 7 and a half.
You can just rotate your stupid.
I know. I'm going to rotate it.
Yeah, but if you can.
Well, so somebody said they think it's 7.5.
I said that.
7 3/4.
This is hard to
8
do.
1/2.
Can you stop talking, please? Remember, I'm trying to record. So that's not perfect, but it's close. Okay. So would I need 2 more of these, you think?
Yes.
All right. So the total amount of tiles needed here is what?
8 and 1/2. 6. 7 and a half.
Okay, so I've heard 8.5, I've heard 6.5, I've heard 7.5. Let's figure it out. So this is 3 units. You still don't need your pencil. And this is 2.5 units. And I'm just going to write a U there because I don't have room. And if I count all these, that's 6. What's a half plus a half?
A whole.
A whole.
7.
So that's 7 plus another half.
7 and a half.
So if I have something that's 3 units by 2.5 units, it's going to be 7.5 square units. Everybody say square units. Okay, now we're going to go draw this. Are you ready? Okay. So on the problem set, looks like I'm going to put it right down here for B. Okay? So get yourself a rectangle. And how long was the top?
3 units.
3 units. And how long was the side?
2.5.
2.5 units. So we got something that looks kind of like that. You agree? I'm close anyway, right?
Pretty accurate.
And we said this was 3 units by 2.5 units. Does anyone remember how long it was, or what the total area was?
7.5.
7.5
Square units.
square units. Okay, so I want to write this problem down, and I just want you to look at it. 3 times 2.5. Don't worry about writing it. We figured out it's 7.5, correct?
Yeah.
So I can't just multiply 3 times 2 and stick a half on the end, can I? No, I can't. I have to make sure I multiply 3 times 2 and then 3 times a half. And I'm going to show you a trick for this later, but let's just keep doing the tiles for now. Okay? So go back to this. Okay? So here's our next, oh, this is long. I remember now. So I can see it all now, can't I? All right. So what are we thinking here? Drag a 1.
Use 1/2
Use 1/2
and repeat.
and keep repeating.
Yes.
So how long do you think this is going to be? Or this is actually the width, isn't it? The side is going to be the width today. 5. I know those halves aren't perfect, and I'm kind of in a hurry. So what do I have here?
7.5.
So I have 5 times 1.5, correct? And this is units. So we'll draw this in a minute. So is this rectangle C? 5 units times 1.5 units. And somebody said it was 7.5. Is that right?
No.
Let's look. Whoops. Okay, so if this is one hole, and this is one hole, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7 and a half.
7.5 square units.
So it's the same answer, isn't it? Totally different shape though, square unit. All right, so now we're going to draw this. And I'm going to make it big enough so I can actually. So how wide, or what was the length on top? 1.5 units. And how wide was it?
5 units.
5 units. Okay. So rectangle C is 1.5 units long and 5 units wide. And what did we determine the total area was? 7.5 units. Square units. Very good. Okay, we have 2 more that we're going to work on. Let's go back to the tiles. Okay, so this one. Just want me to drag the one,
Drag another one to the left.
drag another one.
3/4. And then you wait, use that one.
I wonder if that's why I turned the 3/4 sideways. You think?
Yes.
Yes. Now, in a perfect world, that 3/4 would have went with it. So I don't know what I did wrong when I made this, but you can remember this as 3/4, can't you?
Yeah.
What if I do that? Will that help?
Yeah.
Okay. So what do I have here? 2 units
By 1
by 1
3/4.
3/4 units. So let's put that on our chart. So I know from making chocolate chip cookies, Nestle Toll House recipe, that it called for 3/4 cup of sugar. And I also know if you make one recipe of those cookies, you're going to eat at least half of it eating the dough. Anybody agree with me?
Yes.
Okay, so you're going to want to double the recipe. And so since I was a kid, I've known how to double 3/4 because I didn't want to count in 6 of those things because it would be 6/4, wouldn't it?
Yes.
3/4 plus 3/4 is 6/4. So if I change 6/4 to a mixed number,
That would be 1.
1 and 2/4, which is
1.5.
1.5. So now you had your little baking lesson today, okay? If you need to put 3/4 cup of sugar in and you want to double it, how many cups is it going to be? 1.5. Okay, so we're going to add 1 plus 1 plus 1.5. So what are we going to get?
3.5.
3.5
Square units.
square units. And we're going to draw this now. Okay? All right, rectangle D. And it doesn't have to be to scale. So how long was the top?
2 units.
2 units. So that means split it down the middle here. And 1 and
3/4.
so kind of like that. Yeah. Oh, I forgot units. So we said 2 units times 1 and 3/4 units is 3.5 square units. My rectangle's a little tall, isn't it? All right, so let's look at the last one. And it's another long one. And we still can't see it. All right. So what are you thinking here?
Just half. Bunch of halves. 3/4.
How about a bunch of 3/4?
Yeah.
Okay,
And just repeat.
and just keep repeating it.
Yes. Use a half. Oh, never mind.
Okay, so I've got how many on the side
5.
and how many on the top?
3/4.
3/4. And we need to fill in the chart. Okay, so I've got, whoops, that's backwards. 3/4 times 5. How are we going to figure this out, guys?
Oh, so you take 2 of them and then
Write this, everybody write this down. Yeah. Have we done problems like this before?
Yes.
Yeah, we did. We took the numerator times the whole number, didn't we?
Yes.
And then we kept the denominator. So this would be, what's 3 times 5?
15.
So 15/4. Okay? Now all I have to do is change that to a mixed number. So 5 times 3, right? 5, 10, 15. Oh, it's 4. Okay, so how many 4s will fit in? 3. 3 times 4 is 12. And then how many more to make 15?
2.
So on this one, we can just solve it. We don't even have to use the visual. But I want to see if that's right. You guys want to see if that's right?
Yes.
Okay. So remember we said 3/4 plus 3/4 was 1.5? Okay. So if that's 1.5, and this is 1.5,
3.
what's that total?
3.
And then how much right here?
3/4.
So we got it. All right? Okay, so on the paper, let's draw that. And this was a 5?
Yeah.
Okay, so it's 3/4 units long by 5 units wide. And what did we say that was?
3 and
3 and
Oh, 3 3/4.
3/4 square units.
3 3/4 square units. Okay, so that's the lesson concept for today. Now I want to go back. We can finish that problem set. That'll be fun. But before we do that, I want to go back and do that page we skipped. So that page we skipped looks like this. And I'm going to modify it a little bit because I want to show you a really cool way to do what we did today. Sound good? Okay, so I'm going to modify it. It's going to be a mixed number times a whole number. And your eyes need to be up here. So I'm going to show you 2 ways to solve this, okay? And we're not going to draw all the tiles because that would take a long time, okay? But we are going to draw an area model. So I'm going to show you how to draw an area model and then I'll show you how to solve it numerically, okay? So scoot your area model over here. And it's going to be 3.5 times 2. And it doesn't have to be to scale. Now remind me how to use an area model. There's one of you that remembers? We use these when we were doing multiplication. So what do I multiply here? 2.
2 times 3.
Okay.
And 2 times 1/2.
So what's 2 times 1/2?
1.
So the answer to this would be
7.
7. Okay, now I'm going to show you how to solve it numerically. When you solve it numerically, you're going to add 2 multiplication problems together. Okay, so write this down and show me what I multiplied. I did 2 times 3, right? And then what did I do?
2 times a half.
2 times a half.
Equals 7.
Okay, so that equals 6 plus 1, which equals 7. Okay, that was a super simple one. Let's try one that's a little harder. Okay, so we're going to start by drawing the area model and solving it that way. So this is 3 1/3 times 2. Just a minute. All right, so remind me what we do here. 2 times 3 is 6. 2 times 1/3. What's 2 copies of 1/3?
2/3.
2/3. So my answer is
6 and 2/3.
6 2/3. Okay? Now, what would that look like numerically? Pretty much the same thing. So take a look at this. Okay, so what do I multiply first?
2 and 3.
The 2 and the 3. And then I multiply the 1/3 times the 2. And that gives me 6
6 plus 2.
and 2/3. How you doing?
Good.
Okay. So this is how you do the math without those tiles to drag down over a rectangle. Okay. I feel like this one's going to be harder. You guys feel like it?
No.
So let's see if it is. So I've got 3 4/5 times 4. Okay, you with me? Okay, what's 4 times 3?
12.
And remember, when we take a whole number times a fraction, we take the whole number times the numerator.
16/5.
Okay, and I kind of want to change that to a mixed number, don't you? So how many times does 5 go into 16?
3 times.
So that's going to be 3 and...
1/5.
So 3 1/5 plus 12.
Is 15 and 1/5.
Okay. Now let's do that numerically. But I don't want to rush you. Are you ready to go on?
Yeah.
Okay. So if I solve that numerically, it's going to be 2 multiplication problems that I add together. So the first one is my whole numbers. 3 times what?
4.
3 times 4. And my second one is 4/5 times 4. So what's 4/5 times 4?
16.
Okay, so I've got 12 plus 16 fifths, and we said that was
15, 1/5, and 1.
3 1/5. Okay, so how do you feel about this? Let's see if we can solve some harder problems. You want to? Okay, so let's go to the back of the problem set. This is pretty tricky. I think I want to do this second one first. Okay, and then we'll go back up if we have time, and we'll do the top one. So eyes up here. Look, don't start on number 6. Go straight down to number 7, and I'm going to read it. A rectangle has a perimeter of 35.5 feet. If the length is 12 feet, what is the area of the rectangle? This is a problem you're going to see. Now, what do you notice first of all?
It's area. And it's a rectangle.
It's a rectangle. We need to find the area. What do we know? We know that's 12 feet. And we know that all the way around is 35.5. So that means if I add all the sides together, I'm going to get 35.5. So how am I going to figure out these 2 missing sides and this one? Okay, so tell me one thing, Angel.
Do 12 times, 12 plus 12.
You're right. Since it's a rectangle, we know that these two sides have equal length and these two sides have equal length. Okay, now what should I do? Dusty, what should I do next?
After you added 12 plus 12,
Okay, what's that?
24.
24.
And then you figure out 24.
Is that what you were going to say? 35 and a half minus 24?
Mhm.
Okay, so what's that?
That is 11. 11 and a half.
You can't forget your half, can you? So that means that
11 and a half.
the right side plus the left side equals 11 and a half when I add it together.
11 and a half.
Now I know that 5 and a half plus 5 and a half is 11. Did anybody else know that?
Yes.
So how could I add another half in there? Let everybody think for a minute. Aaron, what are you thinking?
So if we need to split the halves between the two sides, 2/4 equals a half, so 1/4 for each side.
So right now I know this, right? I'm writing 5 and a half like that because it's easier. Okay? That's what I know. I know that those two would equal 11. Okay?
Add a 1/4 to that.
How do I add another half?
You 1/4 on each 5 and a half.
You're right. 1/4 on each side. So instead of 5 and a half, what's it going to be?
5 3/4.
Yep, 5 3/4. Now we're not even done.
Ooh, now we add them up.
No, we know they equal 35 and a half. We've already got that established. We got to figure out the area. So how am I going to multiply 12 times 5 3/4? You want to use the area model?
Sure.
Or do you want to solve it numerically?
Numerically.
Okay, so let's see if we have time to do both. So 12 feet times 5 3/4 feet, right? So let's start with the area model. I think I'll put it up here, guys, so I have enough room. So this is 12, right? Remind me how I do this. Is that right? Yeah. Javen, are you focusing here? Could you finish this problem on your own? So help me multiply. What's 12 times 5?
60.
Okay.
60.
And 12 times 3/4,
6 equals
let's see. 12 times 3 is 36. Are you sure it's 6?
Oh wait, 7.
What's 36 divided by 4?
That would be
9.
So we're saying the answer is 69 square feet.
Oh yes.
Right? 60 plus 9. Now I want to show you how to solve that numerically. You need to write this down, please. If I were going to have two multiplication problems that I add together, I would do 12 times 5 and 12 times 3/4. So that would be 60 plus, did we already figure out? 36/4 would be 9
equals 69
square feet. Okay? That was a good problem. Several steps. Okay? Let's go back up and look at this one. We have time and it's kind of fun. So the rectangle to the right is composed of squares that measure 2 1/4 inches on each side. So each of these is 2 1/4 inches. So let's rewrite it bigger. So we've got 2 1/4 and 2 1/4. And I think I'm going to use the area model. You guys okay with that?
Yes.
All right. So get your area model drawn just like I did. Okay, so 2 times 2.
4.
2 times a fourth.
2 fours. 1/2.
1/2. Good. A fourth times 2.
1/2.
A half. And a fourth times a fourth.
16.
2/16.
Good. 1/16. So let's see if I could add that all up. 4 plus a half, so that makes 5.
5 and 1/16.
So in each box, here's what we have.
Add them all.
Add them all, or do you want to multiply them all? Multiply them all? Okay, so how many total squares here?
12.
So 12 times 5 and 1/16. We can do this. Let's solve it numerically. Okay? So first, multiply your whole numbers.
12 times 5.
And then 12 times 1/16. Don't say any answers. So I've got 60. Twelve sixteenths, right? Everybody understand how I got 12 sixteenths?
Yeah.
I took 12 times 1. Now, I think I could simplify this. What could I divide by?
2.
Bigger.
4.
Okay, so that's going to be 3. So my answer here is 60 and 3/4 square inches. That was a lot of math we did today, and it's just going to keep getting harder. How you doing?
Good.
You like the area model? You like numerically? Which one you like better? Area? I feel like it's a good way to start. All right, these both go in this order.